Welcome, dear friends. Myself, Dr. Rahul Kumar Udehiya. I am working as an assistant professor in Department of Veterinary Surgery and Radiology in Faculty of Veterinary and Animal Science, Banaras Hindu University. So let's start. Today we are going to discuss about the basics of diagnostic ultrasonography. So first of all, we will discuss about the lecture which we are going to discuss today. So first we will discuss about the definition, then history, production of the ultrasound, type of the transducer, mode of the display, ultrasonic image formation, various terminology, application of the ultrasound, advantage and the disadvantage of the ultrasonography, and finally conclusion. So first of all, the definition, what is ultrasound? Ultrasound is nothing, it is a sound wave which we cannot hear or it cannot be audible. That means the frequency of the sound wave is more than 20,000 hertz. So the diagnostic ultrasound is range between 1 to 20 megahertz. So the physics behind this ultrasound is there is conversion of electrical energy into the sound wave and vice versa. So let's start about the history of the ultrasound. So the ultrasound or the work of the ultrasound was started in early 1900 century. In 1880, the Curie was work over the piezoelectric crystal which is producing sound, and that energy is converted to the electrical energy. Afterward, the progress is going on in the ultrasonography. The first medical diagnostic ultrasound was used in 1940 by Dr. Dussig in Vienna. He was used A mode or the amplitude mode for the diagnosis. The first veterinary application of the ultrasonography was used in sheep for detection of pregnancy in 1966. Then color Doppler was discovered. The color Doppler of the fetal arterial flow was reported by Dr. Meda in 1966. In millennium year or late 1900, means 1990 to 2000, the maximum discoveries of in the ultrasound field was recorded. The ultrasonic examination in veterinary practice is a routine in those years. The development of the 3D and the 4D ultrasound machine was going on in those years. Nowadays, in 2025, the ultrasound machine comes with the artificial intelligence enabled. Nowadays, Some portable ultrasound devices are also available which we can attach with the mobile phones. Some other important features are also added in new ultrasound machines like shear wave elastography. That elastography can use to measure fibrosis of an organ. The robotic ultrasound system is also used nowadays. Now let's discuss about the production of the ultrasound. The ultrasound is based on the pulse echo principle. The transducer, which is containing the piezoelectric crystal, which is produce a sound wave in the form of pulse, which transmitted into the tissue, and then the tissue is reflect back that sound wave in the form of echo. That echo is received by a transducer and it converted into the electrical energy. So, the piezoelectric crystal is containing lead, zirconate, titanate. The frequency of the transducer is determined by the time of crystal expand and contract per second. Let's discuss about the part of an ultrasound machine. So, the outer part is a transducer which is touched to the animal. That transducer is attached with the CPU. That CPU is used to convert the digital to the analog. In the CPU, there is transducer control, keyboard, disk storages and display are attached. But you can attach the printer separately with the CPU. So, these are the parts of the ultrasound machine. Let's discuss about the type of the transducer. So, there are three transducers commonly used in the routine practices. The linear transducer or linear array. This linear transducer is containing the linear arranged piezoelectric crystal, which is producing a rectangular shape sound beam, and we have to see a rectangular image on the screen. Curved array or convex transducer. In this transducer, the piezoelectric crystal placed in a curvy manner. Another is a phased array or this transducer containing only one piezoelectric crystal. This phased array transducer is also called as sector transducer. This sector transducer produces the fan shaped sound, so that we can see a fan shaped image in the display. So, again this is a ultrasonograph of all the transducer. The first ultrasonograph is produced by a rectangular shaped by a linear transducer. Another is a microconvex transducer, which is produce a fan shaped image. Then sector transducer, which is produces a fan shaped image. So, this table is showing all type of transducer which is commonly used in our veterinary practices. So, the linear transducer is having higher frequency, that means it is containing 5 to 12 megahertz frequency, so that it is having a very good resolution over the image, but it is having a poor penetration power. Because of that, these linear array transducer are used in vascular sonography and tendon sonography. Next one is a curved or micro convex or the convex transducer. This is having frequency in between the 2 to 5 megahertz. The resolution for this transducer is average, but the penetration power is very good. So, mostly this transducer is used for scanning of abdomen or the abdominal organs. Last one is sector or phased array transducer. The frequency of this transducer is 1.5 to 4 megahertz. It is also having average resolution, but the penetration power is good. That is why this type of transducer is used for cardiac imaging or echocardiography. So, these pictures are showing the resolution as well as the penetration power of the transducer. If the commonly used transducer is ranged from 1 to 20 megahertz, but in our veterinary practices the 3.5, 5 and 7.5 megahertz are commonly used in most of the animal. If the megahertz is increasing, the resolution power is increasing. If megahertz are decreasing, that penetration power is increasing. So, this is about the available transducer. Now, let us discuss about the modes of the display. So, in the ultrasonography, there are 3 modes commonly used. So, first mode is amplitude mode or A mode. So, this is very used a very long time ago whenever the ultrasound was discovered. So, in A mode there are spikes is seen over the display. That spikes denotes the intensity of the returning echo. In the A mode, the horizontal line is also visible, that denote the distance, while the vertical line is denoting the amplitude. Nowadays, this A mode is used in the ophthalmic ultrasonography. Next and very common mode is B mode or the brightness mode. This B mode produces a cross-sectional gray scale images and it produces the echo dots on the screen. So, this is a common mode of the ultrasonography, so that it is commonly used to scan the abdominal organ. Next is a motion mode or the M mode. So, these type of mode is used for the real time movement of the organ. So, this type of mode is generally used in the echocardiography or movement of the heart. So, how the image is formed in ultrasound? So, as we have already discussed in previous slide, the sound is produced by the piezoelectric crystal in a transducer. It goes or penetrate the tissue, interact with the tissue, revert back in the form of echo, again it received in the form of echo and it sent it to the CPU and image is formed. Let now discuss about some properties of the ultrasound wave. So, there are some terms which is related with the ultrasonic waves like attenuation, absorption, reflection, scattering, refraction, diffraction. Whenever the sound wave is interact with the tissue, it may get attenuated. That means the frequency of the sound wave may get attenuated. Absorption of the ultrasound may be in the tissue is during scanning. The absorption during ultrasound is generally used in the therapeutic ultrasound. Next is reflection. The reflection is a common property of ultrasonic wave which is used in a diagnostic ultrasonography. Other property like scattering, refraction and diffraction is causing artifact in the ultrasound. So, in the diagnostic ultrasonography, reflection is a common property which is seen in the tissue. The amount of the reflection is depends on the acoustic impedance. The acoustic impedance is measured by the tissue density multiplied by the sound velocity. The amplitude of the returning echo is proportional to the difference in acoustic impedance between the two tissues. The 50% of reflection is recorded in the interface between the soft tissue and the bone, while the 90% of reflection was recorded in interface of the soft tissue and the gas. So, this chart is showing the acoustic impedance in various type of tissue in a body and the velocity of the sound in different type of tissue in a body. So here you can see the bone is having higher acoustic impedance and the velocity of the sound, while the lowest is air. It is having velocities lowest as well as acoustic impedance is lowest. Now we will discuss how the image is formed on the monitor. The amplitude of the each reflected wave is converted into the electrical signal, which is represented by a dot on a screen. The position of the dot represents the depth from which the echo is received. The brightness of the dot is related to the strength of the returning echo. These dots are combined to form a complete image, so that this image we can see over the monitor. The spatial resolution in ultrasonography is referred to the ability of an ultrasound system to distinguish two separate structures that structure are close together. If the structures are one behind to the other, is called as spatial axial resolution. If the structure are located side by side, is called as spatial lateral resolution. Another term is contrast resolution, which distinguishes between difference in echogenicity or brightness of the adjacent tissue. Another term is a temporal resolution, which depicts to moving structure over the time. So, frequency of the transducer is increased. That means the depth of the scan is decreased, while the resolution of the ultrasonography is increased. So, these three arrows are denoting the frequency, depth of the scan and the resolution. Let us discuss about the terminology which is used in the ultrasonography. When you are interpreting any ultrasound image or ultrasonograph, so you have to use these terminologies like hyperechoic. That means there are increased echo, means white area present over the ultrasonograph. So, it represents the non-uniform structure present in the body, while the hypoechoic, that means the low echo, that means the more gray areas which represent the homogeneous tissues. Anechoic, there that means no echo. It represents the black area, represent the homogeneous tissue or the fluid. Apart from these three terms, one another term is isoechoic. That means the tissue which is having same echogenicity is called as isoechoic. Some example we have to discuss here. Spleen should be hyperechoic to the liver, while the liver is hyperechoic to kidney. That means kidney is hypoechoic as compared to the liver. The very important point related to the ultrasonography, that the ultrasonography demonstrate the structure of tissue rather than the tissue type. So, always remember this important point whenever you are performing a ultrasonography. So, here you can see the ultrasonograph. This ultrasonograph showing anechoic area. The marked area is showing anechoic. It is whole black area. The fluid or a water is showing anechoic area. That means it does not producing any echo. Now, echogenicity, here we will compare the hypo versus hyperechoic region. The first ultrasonograph is showing hypoechoic, while the second is hyperechoic. The echogenicity is increased in second ultrasonograph. So, this ultrasonograph is showing the similar echogenicity in isoechoic. Let us discuss about the application of the ultrasound. So, nowadays ultrasound is widely used to diagnose a disease condition, especially related with the soft tissue, and we can screen the organ with the help of this ultrasound. The ultrasound always act as a complementary imaging procedure for the radiography. Let us discuss about the advantage of the ultrasonography. So, the ultrasonography is used as a evaluation of animal with poor abdominal detail. With the help of this, we can view the internal anatomy of the organ. With the help of this USG, we can characterize the masses or tumorous growth. We can visualize the motion of movable organs, for example, heart, intestine, etc. So, with the help of this ultrasonography, we can take a biopsy or the most important advantage over the X-ray is it does not have any ionizing radiation. So, it is very safe to use in pregnant animals. So, these are the certain advantages of the ultrasonography. Now, let us discuss about the disadvantages. So, as you know that the animal patients are having lot of hair, so that the clipping of hair is must to perform a ultrasonography in veterinary patients. To minimize the transducer skin contact, use acoustic coupling gel to make a proper contact with transducer and the skin. Fasting is required in animal if anesthesia should be given. Full of bladder or full of urinary bladder is also one of the major requirement for scanning of contrast agent is one of the disadvantage. Cavitation in the organ is recorded in continuous ultra. Now we conclude the today's lecture. So, the ultrasonologist should have a proper knowledge of topographic anatomy so that he is able to perform ultrasonic examination in the end. He should very much familiar with the machine so that the artifact can be minimized. Animal preparation should also mandatory before performing the ultrasonography. Select highest possible frequency transducer for abdominal ultrasonography as well as in large animal ultrasonography. So, these are the certain conclusion regarding this basics of the ultrasonography. Thank you.